Okay, this lesson is how to convert between particles and grams. So we're going to do a couple of problems that go from particles to moles to mass, or from mass to moles to particles. These are going to be fence posts that have 3 sections in them, and the way that you'll recognize the problem is it'll say, given so many grams, find the number of particles, ions, atoms, molecules, or formula units. Or, here's how many molecules or atoms or whatever there are, find the mass. So notice there's no direct pathway between particles and mass, so you have to go to moles in the middle first. Okay, here's an example problem. Let's do this one, number 2C on this worksheet. No, let's not. That's too easy. Let's do 3B, how about? How many atoms in each of these? In this one, you're given 7.02 grams of silicon. Okay, so we want to know, given grams, how many atoms? So we're starting with 7.02 grams of silicon, so we're over here, and we're trying to find out how many atoms that would be, so we're going to go here. So set up your fence post, 7.02 grams of silicon over 1. I need grams to cancel, so I put grams of silicon on the bottom. I need to change it into moles first, so moles of silicon on top. Now I need moles on the bottom, so moles of silicon will cancel. And I'm looking for atoms, so atoms of silicon on top. Notice this way I get my units to cancel out. Got to have atoms at the end. So next I can go through and fill in the numbers that I need. See, grams of grams, moles of moles, cancel out. It's going to give me atoms at the end. So for this part, grams per mole, this little slash right here counts as your per line. When you say grams per mole, it's this line right here for the word per. It means divided by. But I'm going to have to look up silicon on the table. And it's not on that one. Wonderful. Silicon is 32.1 grams per mole. So 32.1 grams for every 1 mole. Okay? And then in 1 mole of silicon, there are 6.02 times 10 to the 23rd atoms of silicon. Right? So now we're ready just to do a little math. Remember, we multiply all the numbers on the top and divide by the numbers on the bottom. 7.02 divided by 32.1 times 6.02 seconds, comma, to get that little e, 23, enter. And this answer is, I need 3 significant digits, so I'm going to round it off to 1.32 times 10 to the 23rd atoms of silicon. Well, it must be 5 o'clock. It must be 6 o'clock. The lights went off. Thank you, Erin. Okay, let's do the one on the bottom. What is the mass in grams of 8.42 times 10 to the 18th atoms of bromine? Thank you for turning the lights on. So I'm going to go from particles, which is atoms. Now I'm going to go to moles and then to grams. So let's set this one up. Okay, 8.42 times 10 to the 18th atoms of bromine over 1. Need atoms to cancel, so atoms on the bottom. Changing it to moles, so moles on top. Then moles on the bottom, so it'll cancel. And what am I doing? Grams. Grams of bromine on the top. Okay, this way, atoms of bromine cancel, moles of bromine cancel. It's going to give me grams of bromine. Okay, there are 6.02 times 10 to the 23rd atoms of bromine in 1 mole. And bromine's molar mass is 79.916, so 79.9 grams for every 1 mole. Alright, so what I do next is multiply the top, divide by the bottom. 8.42 E18 divided by 6.02 E23 times 79.9. I need 3 sig figs in my answer. So this answer is going to be 0.00112 grams of bromine. Remember, zeros in the front don't count for sig figs. Or you could write it, if you wanted to, as 1.12 times 10 to the minus 10 to the minus 3 grams of bromine. Okay, so to review these two problems, I'll get that one mixed up with the other one. When we went from grams to atoms, we first divided by molar mass and then multiplied by Avogadro's number. In this problem, we went from atoms to grams. We divided by Avogadro's number first, and then we multiplied by molar mass.